show that the sum of m plus nth and m minus nth terms of an arithmetic progression is equal to twice the mth term. Say, for any arithmetic progression, formula for nth term is a plus n minus 1 into d. So we are applying this formula in this question. Now in this formula, if we replace n by m plus n, then we can get m plus nth term. So from this formula, a m plus n. Now what I am doing, I am putting here m plus n. So whatever you put here, same value we keep here. So it is equal to a plus m plus n minus 1 times d. So here m plus n, so I am putting here m plus n. So this is m plus nth term. And now m minus nth term. So I replace this n by m minus n. So I keep here m minus n. So a m minus n is equal to a plus m minus n minus 1 times d. So m minus nth term. So in above formula, n is replaced by m minus n. So this is second result. Now we are adding these values. So from 1 and 2, m plus nth term plus m minus nth term is equal to LHS plus LHS is equal to, see, a plus m plus n minus 1 times d plus RHS of equation 2, a plus m minus n minus 1 times d. So this is m plus nth term, this is m minus nth term. We are adding these two terms. So taking addition of these numbers, a plus a is 2a plus, here d is common, so taking d common, we have m plus n minus 1 plus, here m minus n minus 1 times d. D is taken common. So this is 2a plus. Now you can see that here this n will be cancelled. So m plus m, 2m minus 2n. So 2 times m minus 1 into d. And taking 2 common here, 2 into a plus m minus 1 into d. So now what is it? This is mth term. It is equal to 2 times am. By this formula you can see that here we are getting m. So a plus m minus 1 times d, it is nothing but am. So it is am. So this is equal to am. So sum of m plus nth term and m minus nth term is 2 times, that is equal to twice the mth term. Therefore result is proved. Thus m plus nth term plus m minus nth term is equal to two times mth term. So result is proved. Now in this question, If sum of three numbers in arithmetic progression is 24, we are asked three numbers in AP. Its sum is 24 and the product is 440. Find the numbers. So here let the required numbers be three numbers in arithmetic progression. So in any question, if you require three numbers in arithmetic progression, then suppose them by a minus d, a and a plus d. So in these symbols, we are not taking small a as the first term. Small a in this calculation is not taken as first term. For any three terms in AP, that means order of these terms can be any numbers. This can be 20th, 21st, 22nd term. This can be 11th, 12th, 13th term. But whatever they may be, these are in AP. So their common difference must be constant. And here you can see that common difference we have maintained, it is D. If you add D, next is A. If you add D, next is A plus D. So remember this trick that whenever you require three numbers in AP, always take A minus D, A plus D, because when we will add these numbers directly, we can get value of A. So now see, the next statement is their sum is 24. Here sum of these numbers is 24. So I am adding these numbers a minus d, a plus d, it is 24. So that means adding them, this dd is cancelled. So 3a is 24. So a is 8. So applying this trick directly, we are getting value of A. And remember, this is not taken as first term. Now, product is 440. Now, product of these numbers is 440. Now in this equation I substitute value of 8. So 8 minus d into a into 8 into 8 plus d equal to 440. So multiplying these two numbers, 64 minus d square is equal to 440 divided by 8. So 8 into 5, 40, 4 is left, 8 into 5, 40. So d square is equal to 64 minus 55. So d square is 9. D square is 9, so d is plus or minus 3. There are two possible values of d. So, if d is 3, then the required numbers are, now I am putting values in this equations. See, a is 8, so a minus d, a and a plus d. I have taken d equal to plus 3. So required numbers are 5, 8 and 11. So this is answer 1. And if d is minus 3, then required numbers are, now I keep here minus 3. A is 8. So 8 minus 3, 8 and 8 plus minus 3, that is 11 comma 8 and this is 5. So these are either they are 5, 8 and 11 or 11, 8 and 5. Let the sum of n, 2n, 3n terms of an arithmetic progression be S1, S2 and S3 respectively. Show that S3 is equal to 3 times S2 minus S1. Say for an AP, question of AP, for an AP, formula to find sum of first n terms, formula for sum of first n terms is n by 2 into 2a plus n minus 1 into d. This is formula to find sum of first n terms. Now here sum of n terms of an AP be S1. So this is sum of first n terms of AP. Its value is S1, that is given. So that means I am putting here its value is S1. So S1 is n by 2 into 2a plus n minus 1 into d. See, look here. I am not putting n equal to 1 here. I am putting Sn equal to S1. Let me write in detail. Here Sn is equal to S1. So given that Sn equal to S1, therefore I am putting here S1. S1 is n by 2 into 2a plus n minus 1 into d. So it is sum of first n terms of AP. Let me say it is equation 1. This is formula. We are using this formula. Now see, sum of 2n terms of AP. So sum of 2n terms, so I replace here n by 2n. So S2n again from formula. I am putting here 2n. So putting here 2n. Everywhere, if I keep here 2n, so I have to put here 2n, here 2n. So 2a plus 2n minus 1 times d. 2n, 2n, 2n. So it is sum of first 2n terms. But given that we are given sum of 2n terms is S2. So here I am putting S2. S2n is how much? S2. So that means putting here S2, S2 is 2n by 2, 2a plus 2n minus 1 into d. It is equation 2. Now again from formula, this is formula. So again from formula, now I am finding sum of 2n terms, 3n terms of AP. So in this formula I have to put here 3n. So S3n is equal to 3n by 2 into 2a plus 3n minus 1 into d. So 3n, 3n, 3n. So sum of 3n terms. But S3n, given that sum of 3n terms is how much? S3. So given that sum of 3n terms is S3, here S1, S2, St, these symbols are given as values. This does not mean sum of one term, sum of two terms, sum of three terms, because in formula we are using Sn symbol. So putting S3n equal to S3, therefore S3 is 3n by 2, 2a plus 3n minus 1 times d. Now we want to prove this result. So I am beginning from right hand side. Now we want to prove S3 equal to 3 into S2 minus S1. So taking RHS of this result is 3 times S2 minus S1. So 3 times. Now value of S2 is 2n by 2 into 2a plus 2n minus 1 times d. So this is S2. This is S2 minus S1. S1 is n by 2, 2a plus n minus 1 times d. So this is S1. So 3 times S2 minus S1. Now simplifying this, 3 into, now see, here we want to prove that it is equal to S3. We want to prove that it is equal to S3. That means we want to prove this will be equal to this value. This is required RHS in the last step. At last we want to show that this is equal to S3. S3 means we want 3n by 2 into 2a plus 3n minus 1 times d. So to beginning from RHS to derive it is equal to LHS. This is LHS. We have to derive this expression in the last step. Now we want this expression and we are at here. So look here, with 3 we want n by 2. So now what I am doing, I am taking n by 2 common. So n by 2 common. Inside what is left, 2 into 2a, that is 4a plus 2 into 2n minus 1 times d, 2 into this number, 2 into this number, minus 2a minus n minus 1 times d. After taking n by 2 common, whatever is left that I have written. So that is 3n by 2 into 4a minus 2a is 2a. Look, we are getting plus, say here, d in these numbers d is common. So taking d common, 2 into 2 4n, 2 into minus 1 is minus 2, minus n plus 1, minus n plus 1 times d. So this is now 4n minus n is 3n, and minus 2 plus 1 is minus 1. So result is derived. So therefore LHS is equal to RHS. If a function is f is a function satisfying this condition, f of x plus y is equal to fx into fy for all xy belonging to n, such that f of 1 is 3 and sigma fx, where x varies from 1 to n, is 120. Find value of n. So here this condition is for all xy belonging to n. Here given that f of x plus y is fx into fy, and we are also given that sigma fx x equal to 1 to n is 120. This means what? If you take x1, so it is f1, then put x2, so f of 2. Sigma does addition of these numbers by putting values of x from 1 to n. So f of 3 plus up to f of n is 120. We want value of n. Now see, to put here values, say f of 1 is given, this is 3, but we don't have value of f of 2. So what we do, in this equation we put x equal to 1, y equal to 1. Putting x1, y1, so this will be f of 2 equal to f of 1 into f of 1. F of 1 is 3, so 3 into 3, so this is 9. So this value f of 2 is 9, f of 2 is 9. Now next we want f of 3. So to obtain f of 3, now what we do, we put x equal to 2, y equal to 1, or take x1, y2. So that will be 2 plus 1, 3. X we have taken 2, y we have taken 1. Now f of 2 already here found, it is 9 into f of 1 is 3, so 27. So this is 27. So we can continue this procedure. It can be continued. So here, putting the values in this equation, we can see that this is nth term. It is nth term. Sum of n terms of this series. Now look here. If I take here 3 common, so inside we have 1 plus 3. Okay, keep it as it is. Observe this series. This is sum of terms of geometric progression. This is the series related to GP. So here first term a is 3, then every number is multiplied by 3, so ratio is 3. So we are putting these values in this formula. Sn is a into r raised to n minus 1 upon r minus 1. So using the formula, sum of n terms of this GP, that is a is 3 into r is also 3 upon 3 minus 1 equal to 120. So this is 3 by 2 into 3 raised to n minus 1 is 120. So 3 raised to n minus 1 is 240 divided by 3. So 3 raised to n minus 1 is 80. So 3 raised to n is 81, therefore n is 4. The sum of three numbers in geometric progression is 56. If we subtract 1, 7, 21 from these numbers in that order, we obtain an arithmetic progression. Find the numbers. Sum of three numbers in GP. Let the numbers in GP be suppose numbers are A, AR and AR square. Three numbers in GP, A, AR, AR square. Numbers in GP, so their common ratio should be same. First number is A, it is multiplied by R, so AR, next is AR square. Now, their sum is 56. So here A plus AR plus AR square is 56. Taking A common, 1 plus R square is 56. Let me say this is result 1. Keep inside. Now next statement. If we subtract 1, 7, 21 from these numbers, that means from these numbers. Now from these numbers I am subtracting 1, 7 and 21. So see, A minus 1, AR minus 7, AR square minus 21. From first number 1 is subtracted, from second number 7 is subtracted, from third number 21 is subtracted. So these numbers we obtain in AP. These are in AP. So these numbers form an AP. And if three numbers are in AP, then sum of first and third number is double of second number. So therefore sum of first and third number is double of second number. Whenever three numbers A, B, C are in AP, then A plus C is twice B, because common difference is same. From this equation we will get one result, second result. So here A minus 1 plus AR square minus 21 is 2AR minus 14. Therefore AR square, 2AR take on this side, so minus 2AR plus A keep as it is equal to minus 21 minus 1 I am taking on that side, so plus 22 minus 14. So here A is common, so R square minus 2R plus 1, it is equal to 24 minus 14, that is 8. So this is another result, result 2. Result 1, result 2. We want to find these three numbers, that means we want to find these numbers. So to find these numbers, value of A and value of R are required. So we have to solve these two equations. If we take ratio of 1 and 2, then automatically A will be cancelled. So taking ratio of equation 1 and 2, from equation 1 and equation 2, here LHS upon LHS. LHS upon LHS is equal to RHS upon RHS. So doing this will be cancelled. Here 8 into 7, 56. We are going to have quadratic equation in R. So 1 plus R square is 7R square minus 7 into 2, 14R plus 7. So 7R square minus R square, that is 6R square, minus 15R plus 6 is 0. Dividing by 3, so it is 3R square minus 5R plus 3, sorry, dividing by 3, this will be 2, 2R square minus 5R plus 2 is 0. That is 2R square minus 4R minus R plus 2 is 0. So here we are going to have solution 2R into R minus 2 minus 1, R minus 2 is 0. Therefore 2R minus 1, R minus 2 is 0. So R is 1 by 2 or R is 2. Two possible values of R. Now case 1, if R is 1 by 2, R is 1 by 2, so 1 by 2 now I am putting either in 1 or in 2. We can keep any one equation. Suppose I am putting in 1. So then from equation 1, A into 1 plus R is 1 by 2. 1 by 2 square is 1 by 4. It is equal to 56. So here, so A into, here 4 is LCM, so 4 plus 2 plus 1 is 56. So A is 56 into 4 upon 7. So that is A is 32. So when R is 1 by 2, at that time A is 32. So required numbers are therefore A. What is A? 32. A, then A into R. R is 1 by 2 into A into R square. These are required numbers. A, AR square. That is 32, 16, 8. These are required numbers. That is answer 1. Now second possibility, if R is 2, then again putting in equation 1, A into 1 plus 2 square is 4 is 56. Therefore A is 56 by 7. A is 8. So when R is 2, then A is 8. So numbers are therefore required numbers A, AR square, that is 8, 16, 32. This is second possible answer. So there are two possible triplets. If sum of first 4 terms of an AP is 56, the sum of last 4 terms is 112. If its first term is 11, so here first term is 11, then find number of terms. Suppose there are n terms in this AP. So let me take an is, nth term is a plus n minus 1 into d. This is nth term of this arithmetic progression. So a is 1, so nth term will be 11 plus n minus 1 into d. Now see, so from this equation, so therefore first term is a1 is 11, a2 is, put n equal to 2 here, so a2 is 11 plus d, a3 is 11 plus 2d, a4 is 11 plus, putting here 4 minus 1 is 3d. These are first 4 terms. So therefore given that sum of first 4 terms is 56, therefore 11 plus d plus 11 plus 2d plus 11 plus 3d is 56. Therefore 1 2 3 4 44 plus 3d 2d 5d plus 1d 6d is 56. So 6 times d is 56 minus 44, so that is 12. So d is 2, so therefore we can put value of d in this an. So from equation 1 an is equal to 11 plus n minus 1 into d is 2. So an is 2n minus 2 plus 11, that is 9. So this is an. Now given that sum of last 4 terms, sum of last 4 terms is 1 1 2. Sum of last 4 terms is 1 1 2. This is last term. An is last term. So an, then second from last, then third from last, then fourth from last. Last term, second from last, third from last, fourth from last. Sum of last 4 terms is 1 1 2. Now from this equation, from this 2, an is 2n plus 9 plus an minus 1. So I keep here n minus 1. So 2 into n minus 1. So 2 into n minus 1 plus 9. So this is this number plus n minus 2. So put here n minus 2. So 2 into n minus 2 plus 9 plus n minus 3, n minus third term. So put here n minus 3. So 2 into n minus 3 plus 9. So this is last term. Second from last, third from last, fourth from last. Sum of last 4 terms is 1 1 2. Therefore this is equal to 2n plus 9, 2n minus 2 plus 9, 2n minus 2 plus 2n minus 4 plus 9, 2n minus 6 plus 9 is 1 1 2. So therefore see 1 2 3, 4. 4 into 2, 8n. 8n. 9 plus 9 plus 9 plus 9. 36. 36 minus 6 is 30. 30 minus 4. 26. 26 minus 2. 24. So plus 24 is 112. So therefore 8n is 112 minus 24. So 8n is 88. Therefore n is 11. So number of terms there are 11. So there are 11 terms. Find number of terms. So there are 11 terms. 11 terms in AP. Let S be the sum, P the product, and R be the sum of reciprocals of n terms in a GP. So question is about GP. So first of all, we suppose that GP AR square, so here n terms, so AR square up to AR raised to n minus 1 be n terms of a GP. So these are n terms of GP. Now S be the sum of these n terms. So here S is A plus AR square plus AR raised to n minus 1, and by formula sum of n terms of GP is A into R raised to n minus 1 upon R minus 1. So this is value of S. Now we are coming on P. P is product of these n terms. Now P is product of these n terms, that is A into AR square into dash 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 into AR raised to n minus 1. Product of n terms of GP, its value is P. Here it is given. So here this is equal to, now say this is first term, this is second term, this is third term, this is nth term. So in all these n terms we are collecting all A together, A into A into A into, this is how many times? N times. In second bracket I am collecting here R into R square into R cube into R raised to n minus 1. So here this A is n times, so it is A raised to n. Here R raised to, here bases are same, so doing sum of indices 1 plus 2 plus 3 plus up to n minus 1. This is sum of first n minus 1 natural numbers. Sum of first n minus 1 natural numbers, not n natural numbers. We know formula to calculate sum of n natural numbers. Sum of n natural numbers is n by 2 into n plus 1. So here what is given? It is up to n minus 1. So here I have to put n minus 1. So this n will be replaced by n minus 1. So here n minus 1, n minus 1. So doing accordingly, a raised to n into r raised to, now its value is replacing n by n minus 1, sum of first n minus 1 natural numbers is n minus 1 by 2, n minus 1 by 2 into n minus 1 plus 1. So reason for this step is explained here, because this is the reason. N is replaced by n minus 1 to calculate this term. So this is a raised to n into r raised to, this is n, so n into n minus 1 by 2. So this is value of a p. Let me say it is equation 2. So p is calculated. Now what is r? We calculate r. R is sum of reciprocals of n terms. So now I am taking sum of reciprocals of these numbers, sum of all reciprocals of this series, this sequence. So R is equal to, and R is sum of reciprocals, that is 1 upon A plus 1 upon AR plus 1 upon AR square plus 1 upon AR raised to n minus 1, sum of reciprocals of n terms of GP. So it is equal to, now 1 upon A common, so inside 1 plus 1 by R plus 1 by R square plus 1 by R raised to n minus 1. These are n terms. It is GP. This is GP. Series corresponding to GP. Sum of n terms of GP. First term is 1. First term is 1. Common ratio is 1 by R. And these are n terms. First term, second term, third term. This is nth term. So applying formula to find sum of n terms of GP. So here we are applying this formula. Here first term is 1, common ratio is 1 by R, and using this formula we are using this formula now. So A means first term. What is first term? 1. A into R. What is R? R is 1 by R. So 1 by R raised to n minus 1 upon R minus 1. Say this is these are symbols used in formula. So don't be confused. In formula, small r is common ratio, and here its value is 1 upon R. Here 1 upon R is ratio. Let me change here symbols. A into R raised to n minus 1 upon R minus 1. But same symbols are also used in this question, so we should not use same symbol. So keep in mind that here we are using formula for sum of n terms of GP. Now this is equal to 1 upon A into 1 minus R raised to n, taking LCM, 1 minus R raised to n upon R raised to n, 1 minus R raised to n upon R raised to n, and here this will be 1 minus R, and its LCM we take in numerator. So it is equal to 1 minus R raised to n into R upon A into R raised to n into 1 minus R. Just we keep this as it is. This is r. Let me say it is equation, it is value 3. Now what we want to prove? We want to prove that p square into r raised to n is equal to s raised to n. We want to prove p square into r raised to n is equal to s raised to n. So putting value in left hand side, say left hand side is p square into r raised to n. What is p? P is a raised to n r raised to n into n minus 1 by 2. This is p. P is a raised to n r raised to n minus 1 by 2. So this is value of p. So p square. So p square into r raised to n. This is r. 1 minus r raised to n into r upon a into r raised to n 1 minus r. This is value of capital R and it has power n. So now simplifying this, see a raised to n into this number whole square. So multiplying inner and outer power, it is a raised to 2n into r raised to multiplying inner and outer power, so n into n minus 1 into here 1 minus r raised to n into r raised to n upon a raised to n r raised to n square n, that is n square 1 minus r raised to n. So inner power and outer power. Inner power multiply with outer power. Inner power is multiplied with outer power. So this is equal to this number into let me keep in level. This was a raised to 2n into r raised to n into n minus 1 into this number. So it is equal to, now see a raised to 2n upon a raised to n. So a raised to 2n minus n. Here r raised to n square minus n into n square minus n. Here into r raised to n. So plus n. See bases are same. So we do sum of indices, n square minus n plus n. One more in denominator. Here power is n square. So take in numerator. So minus n square. So these three numbers are connected. Into 1 minus r raised to n whole raised to n upon 1 minus r raised to n. So you can see that this is cancelled. So it is r raised to 0. So 1. So a raised to n into 1 minus r raised to n whole raised to n upon 1 minus r raised to n. Now we want to prove that it is equal to s raised to n. What is s? Look there. We are going to get s raised to n. So this can be expressed as a into 1 minus r raised to n upon 1 minus r whole raised to n. And it is s raised to n. So this is s raised to n. It is from 1. So this is RHS. So it is equal to RHS. So therefore LHS is equal to RHS. Result is proved. If A and B are roots of quadratic equation, C and D are roots of another quadratic equation, where A, B, C, D form a GP, prove that Q plus P is to Q minus P is 17 is to 15. See, we know a rule of a quadratic equation. Rule is, if alpha and beta are roots of ax square plus bx plus c equal to 0, then alpha plus beta is minus b by a and alpha into beta is c by a. We will use this rule in this question. Here A and B are roots of x square minus 3x plus p equal to 0. Therefore, sum of roots is minus b by a. So 3 by minus of minus 3 by 1, that is 3, and product of roots is p by 1, that is p. So using this rule, we have one more statement. Moreover, C and D are roots of x square minus 12x plus q equal to 0. So C plus D is minus 12 by 1, that is 12, and C into D is q by 1, that is q. So we have these two results, result 1, result 2. Now A, B, C, D, these numbers form a GP. Given that A, B, C, D form a GP. Because this form a GP, so A we keep as it is. So here common ratio will be same. So we suppose that B is A into R, C is AR square, D is AR cube. If this is first term is A, this should be AR, this should be AR square, this should be AR cube. So we suppose that B is AR, C is AR square, D is AR cube. Now in this equation, I am putting B equal to AR. So from 1, therefore from 1 I am putting B is AR. So A plus AR is 3. A plus AR is 3. Taking A common, 1 plus R is 3. And here in this equation, I am putting value of C and D. So from equation 2, C is AR square, D is AR cube. It is equal to 12. So these two equations are used. So taking here AR square common, 1 plus R equal to 12. Now here we are taking ratio of these two equations. So from 3 and 4, from 3 and 4. See here, LHS upon LHS equal to RHS upon RHS. So A 1 plus R is cancelled. So 1 upon R square is 1 upon 4. So R square is 4. Now we want this value. So we need value of P and Q. So see what we do now. Here P is A into B. Now what is A? A already is A, but B is AR. So P is A square R. And Q is C into D. What is C? C is AR square. D is AR cube. So it is A square into R raised to 5. So therefore Q upon P is A square into R raised to 5 upon A square into R. Therefore Q upon P is R raised to 4. A square cancel. 1 R will be cancelled. So Q upon P is, say look, R square is 4. So R raised to 4 is, this is R square whole square. So Q upon P is 4 square. So Q upon P is 16. That is 16 by 1. So Q plus P upon Q minus P is 16 plus 1 upon 16 minus 1. Therefore Q plus P upon Q minus P is 17 by 15. This implies this ratio is 17:15.